Welcome back to our Chem 152 video series. In this video, we'll work an advanced precipitation problem. This problem tells us that we're going to start with a solution of Mg2+ and adjust the pH to 10. When we do that, we're going to make some amount of MgOH2. This question asks, how much will we make? First off, let's write a dissolution equation for MgOH2. If MgOH2 breaks, it will break into Mg2+ and OH-. We'll write that we have two pieces of OH-. What's a little unusual about this problem is the amount of OH is going to be known. The OH will be based on that pH of 10. However, somewhat unusually, the amount of Mg we're going to have to go with that is unknown. This may seem unusual considering that we have a molarity of Mg2+. However, we must remember this is going to be the starting molarity. We don't know what molarity this will end at once we've buffered the pH to 10. We can still write a KSP equation. We'll say KSP is still equal to Mg2+ times two pieces of OH-. We'll also note that the OH we can find, the Mg we don't know. So we'll plug in the KSP, which is 1.8 times 10 to the negative 11th. We'll set this equal to magnesium, which was unknown, so we'll call that X. And then the OH- we can find now. We can base our OH- on the fact that we know the pH is 10. We'll say that pH is equal to 14 plus log of the OH. Our pH is 10, and we'll plug that in. And now we'll subtract 14 from both sides. When we subtract the 14, we'll have 10 minus 14 gives negative 4 equals log of OH. Now, to clear this log and solve for the OH, we will take a base 10 exponential on both sides. On the left, we'll have 10 raised to the negative 4th, and on the right, we'll have 10 raised to log of OH. However, the 10 and the log are inverse functions and will cancel out. Therefore, we'll have that our OH will equal 10 to the negative 4, or in scientific notation, that's 1e negative 4. We'll place that in the OH position. We'll remember to write squared next to it. Therefore, all we'll need to do now is divide by 1 times 10 to the negative 4th squared. Therefore, our x will equal 1.8 times 10 to the negative 11th divided by 1 times 10 to the negative 4th squared. If we divide, we'll get 0.0018 molarity for our Mg concentration. This means when we have a pH of 10, we will have 0.0018 molarity of Mg left over. Now that we know that our leftover Mg is going to be 0.0018 molarity, let's compare that against to what we started with. Our starting Mg was 0.002 molarity. Therefore, we'll have a change of 0.002 minus 0.0018. If we subtract, we'll get 0.0002 molarity. This will be the molarity of the Mg2+ that got used up. So now that we know the molarity of the Mg2+ that we used in order to make the compound, now we can convert from molarity to moles, and then from moles to grams, and then from moles to milligrams in order to find how much MgOH2 we made. This will be a 3-step conversion. For the first step of this conversion, we'll start with the molarity we have, 0.0002 molarity, and multiply it by our liters to give ourselves moles. Our liters are given in line 1. We were given 100 ml, which is the same thing as saying 0.1 liters. If we multiply these numbers, we'll get 2 times 10 to the negative fifth moles. For the second step of our conversion, we'll take those moles, we'll get out of moles, and get into grams. To do this, we can use the molar mass of our compound MgOH2. This number will go next to grams. We'll place a 1 underneath moles, and we'll multiply. We will end up with 6.62 times 10 to the negative third grams. Then for step 3, we can take our grams and go to milligrams with it. Remember that 1,000 milligrams is the same as 1 gram, and when we multiply, we'll end up with 6.62 milligrams. This will be the mass of MgOH2 that we make if we adjust the pH to 10 as discussed previously. Once more for good measure, I'll repeat that from our KSP equation, we got the leftover magnesium. This was not our answer. What we had to do was subtract our initial molarity for magnesium minus what we just found from the KSP, and that gave us the change. Then, using the change, we can convert from molarity all the way over to milligrams. That's what gives us the amount of product. Thank you for watching. We'll see you again soon.